So now, according to Clausius statement, no process is possible, which absorbs heat from a cold reservoir and transfers it to hot reservoir. So no such possibility is there. That means if we have a T hot as a source of T hot, means higher temperature, and this is a region which temperature is Tc, then the heat cannot flow continuously from this direction towards that direction. So this is not possible. So in a refrigerator, heat comes from cold to hot, but with the help of some external work done. So without taking any help, such a possibility does not exist. That means no process is possible which absorbs heat from a cold reservoir and continuously transfer it to the hot reservoir. This possibility is not there. So this is the statement of Clausius statement. Now we have two statements, Clausius statement and Kelvin-Planck statement. Now we can prove that both are statements are the same, telling the same aspect of the second law of thermodynamics. So we will prove like this: if Clausius statement is right, then Kelvin-Planck statement is also right. If that is right, then this is also right. If this is wrong, that is wrong. And if Kelvin-Planck statement is wrong, then this is Clausius statement. So we can prove that these two statements are equivalent. So the Clausius statement and the Kelvin-Planck statement are equivalent. That means both explain the same thing. That is what we say second law of thermodynamics. Let us see how. Now let us see that both the statement, Clausius statement and Kelvin-Planck statement are equivalent. So in order to prove that, we will first prove that if Clausius statement is false, that means Kelvin-Planck statement will be also false. If Kelvin-Planck statement is false, then Clausius will be false. If this is true, that is true. If that is true, this is also true. So number 1 point, let us prove that. Let us assume falsity of Clausius statement. So I have assumed that the Clausius statement is false. That means we can have a machine which takes heat from the cold reservoir and can continuously give to a hot reservoir. So what we do, we make a system in which this is hot reservoir and this temperature is T hot. We have a cold reservoir at temperature Tc, T cold. And now I have two engines. This is a engine and this is a this is a engine and this is a refrigerator. So what we did, this refrigerator and engine, this refrigerator takes Q2 amount of heat from the cold reservoir and it can deliver this Q2 amount of energy to the hot reservoir. So which is impossible according to Clausius statement, and I have assumed that the Clausius statement is false. So I have a refrigerator which can take Q2 energy from the cold reservoir and reject it into the hot reservoir. So this is the falsity of the Clausius statement. Now let us assume an engine which takes energy Q1 from here, hot reservoir, and converts some energy into work and rejects some energy to the cold reservoir, that is Q2. So Kelvin-Planck statement tells that no engine can take energy continuously from a hot reservoir and without rejecting converts into works. That means if Kelvin-Planck statement is true, it has to Q2, energy has to be rejected to this, and this work will be equal to Q1 minus Q2. So now I have assumed that the falsity of Clausius statement that such a refrigerator can be made which takes out Q2 amount of energy from the cold reservoir and gives to the hot reservoir. And this is a engine which takes Q1 amount of energy from here, converts it into work, and some part is rejected Q2 into the system. So together this system, let us see what is the work of this system as a whole, R plus E. Now together this system, you see Q2 energy is taken from here and given back. That means cold reservoir is unchanged. What is actually happening here? That Q2 amount of energy. So the process, so we can say the final process. What is the final process? The final process is that this is a engine with refrigerator plus engine, and this is my cold reservoir, and this is my hot reservoir. So no energy is going in the cold reservoir, Q2 amount coming and going. So no energy. So this is nothing here, no exchange of energy between here. So we are taking energy Q2 going and Q1. That means I am taking Q1 minus Q2 and giving work equal to Q1 minus Q2. So the moment I assume that the Clausius statement is false, then I get that we can have an engine which can violate Kelvin-Planck statement also, because without rejecting heat, it is able to convert 100% of that heat directly into work without any wasting. That means if the falsity of Clausius statement is there, that means Kelvin-Planck statement becomes false. So the false, thus the refrigerator plus engine together violates the Kelvin-Planck statement whenever or violates the Clausius statement. That means if Clausius statement is wrong, then the Kelvin-Planck statement automatically becomes wrong. Thus, it seems that both are equivalent.